Hey everybody, welcome back. We are headed to the lab to wrap up some soil testing. ASTM 1883 is what we're talking about, which is the standard test method for the California bearing ratio of lab compacted soils. I know that's a mouthful, so in plain English, rather we're just looking at the CBR test. The CBR test measures and compares the strength of subgrade soils, primarily for road and pavement design. So in the lab, we're going to look at how the soil performs both before and after treatment with quicklime. We've already compacted the specimens in molds. We've completed our standard 96-hour soak, which is important because moisture affects how the soil performs. Essentially, we're looking at worst case scenario, and we can look at not just the bearing capacity. We can also look at how much the soil will swell. Lime products are really good at reducing that shrink swell potential. So without further ado, let's get in the lab and see how the guys are making out. We're going to check back with our samples that have already been prepared in the molds and soaked for the standard 96-hour period. This soaking period is necessary since moisture affects the performance of the soil. Essentially, it gives a worst case value. Soaking also gives us an idea of how much swell can be expected in saturated conditions. Lime products are great at reducing, if not eliminating, shrink swell potential. The first thing we do is check and record the values on those gauges. You can see that 6% and even 3% quicklime treated soils stayed at 0.0, while the untreated soil, did not. This one had about a 5% swell associated with it. I do want to add that 6% quicklime by dry weight of soil is a high dose rate. This was a very high PI, so we need an elevated dose to kind of cut that through that plasticity. It was close to 60. So if you're seeing necessary dose rates over 5%, please reach out to Mintech to talk through things. Back to the test, we disassemble the swell apparatus and get a final weight of the specimen in that mold. Since we know the volume of the mold, we can determine the unit weight of that soil after soaking. We'll compare it to the unit weight before soaking, and generally, the unit weight of a good performing soil would not change much after soaking. That is, not much water will be able to infiltrate that soil matrix. Once we have that weight, we're ready to set up for the test. We put two 5-pound surcharge weights on top of the soil. Remember, the CBR is a confined test. These weights help to mimic a pavement on top of that soil. Once the testing apparatus is set up, penetration testing can begin. We force a standard plunger into the sample, measure and record the pressure, and divide it by the pressure that's required to get an equal penetration on a standard crushed rock material. CBRs range from 100, being that crushed rock, to 1, indicating a very poor material. So as we're doing this testing, we can create a load penetration curve showing the stress on the piston versus penetration. And the final step in the lab is to determine the final moisture content of the soil by drying it overnight in an oven. CBR values are usually recorded and reported at 0.1 inches, but if the CBR at 0.2 inches is greater, we'll report that value. It's not uncommon to see low values drastically improve after treatment with lime. Here in the Mintech lab, we've seen CBRs easily 10 times higher after treating with lime. So what is all this for? Well, pavement design engineers can use these CBR values to help determine the thickness of pavement layers. Lime-treated soils can help reduce the thickness of a pavement, saving time, money, and resources.